right in my ear. You're making me go deaf. I'm filming. Ready, go. Nice job. Give me 5. Yeah, man. All right, let's go. Let's do some math. You see, if we let x equal the vertical distance from the top as he moves down the slide, and we let f of x equal the angle of rotation of his body around that center pole, we can write a function that takes the vertical distance as an input and outputs the amount of rotation. Given that he rotates 720 degrees over a 12-foot drop, that's 60 degrees per foot. Let's simulate it. This simulation takes length as an input and outputs rotation. First, we'll set the domain from 0 feet to 12 feet, setting the length to go from 0 to 12. Then, we set the rotation to be 60 times the number of feet, and boom, we got ourselves a simulation of the situation. As the number of feet move from 0 to 12, the rotations go from 0 to 720. Oh! Let's do more math. In this case, x will equal the number of times his hands move from one rung to the next, and f of x will equal the linear distance from the left side to the right side as he moves along. Since the rungs are about 15 inches apart, we've got a rate of 15 inches per rung. This simulation takes a number of objects or actions as the input and outputs a length, perfect for our situation. We'll start by setting the number of rungs from 0 to 6, and then we'll multiply the number of rungs by 15 to get the distance he's traveled from the left side to the right. And once again, we've got a beautiful simulation that models the situation. As the number of rungs goes from 0 to 6, the distance goes from 0 inches to 90 inches. More math. Let's let x equal time, and f of x equal the angle the swing makes with the vertical. This is a sine function. With our period being about 3 seconds and our amplitude being around 35 degrees, we're ready for our simulation. This simulation takes time as an input, represented as a slider, and outputs a rotation. The first thing we'll do is change the time interval from 0 to 10 seconds. Then we'll input the function, 35 times sine of pi over 3x minus 90. And once again, we have a beautiful simulation of the situation. Oh, here comes the little guy.
Daddy.
Yeah?
Come here.
Hold on, you gotta be in this video, ready? Harry O'Malley here, and this is my first vlog. Yeah, smile. You're on camera. This is just a place where I'm gonna share, things I make for math teaching. I hope you like it. If you do, please subscribe. I'm gonna try to come out with these as regularly as possible. What do you guys think? Would you subscribe to my videos?
Yes!
Good. See you soon.